Okay, today we're going to introduce equations, and we mentioned that last time when we were talking about expressions. So from here on out, I got to make absolutely sure or be really careful of whether I have an expression versus an equation. An equation has an equal sign, okay? You can solve an equation. An expression does not have an equal sign, and we can't solve it. Right? You can't solve it. You can only simplify it like we were doing last time. Okay, I'm just going to put them all up there. So these equations balance, right? That's kind of what an equal sign is. It means it's the same on both sides. 6 plus 8 is the same thing as 14. 5 times 2 is the same thing as 10. 3 times 2 is 6, which is the same thing as 5 plus 1. So it doesn't matter what your equations look like, but when there's an equal between them, or I guess I should say, it doesn't matter what your expressions look like, but when there's an equal between them, they have to equal the same value. And you can see these over here are not equal because 4 plus 5, 9, is not the same as 20. Okay, so to solve an equation, right, we're trying to find a number that we can replace the variable with that will make this balance. Notice maybe we can tell from just looking at this that C should be 25 because 25 plus 5 would be 30. Okay? And they're just trying to replace it with different numbers until they find the exact one. We don't want to just go around guessing, so let's see if we have a method. We have something called the addition property of equality. Okay, it says if we have two things that are equal, and remember they may look different, it might be 5 plus 1 and 3 times 2, but as long as I add the same thing to both sides, it's going to stay equal. Okay, notice here, if we added 2 more people on the balance beam, as long as we put 2 more on the other side, it's still going to be equal. This works for anything. I could have subtracted 2 people. Whoops. I could have subtracted 2 people. As long as I subtracted 2 people from both sides, it would still be equal. Okay? I could have doubled the number of people. In other words, put 2 times 3 people, 6 over here, and 2 times 3. As long as you do the same thing to both sides. Okay? Then we're going to use that idea to solve equations, meaning until we get an equation worked down so that all I have on one side is my variable and on the other side a number. And then we'll consider it solved. We'll have x equals some number. That's our goal. So we're going to make what we call equivalent equations using those properties. So for example, that one we were talking about, what we're going to do using our addition property of equality is I want the C all by itself. I don't want any numbers over here. So if I have a plus 5, I'm just going to do minus 5. I just have to remember to do the same thing to both sides. The reason that I did minus 5 is because now that's 0. Plus 5 minus 5 is 0. And C plus 0 is just C. And then 30 minus 5 is 25. And of course we already knew that was the quotient. You can hear my dog snoring again. He likes to come in here and lay when I'm doing these. I don't know why. Okay. All right. So the same thing. So we're going to practice with a few equations where all we have, they're short and simple, and all we have is one number being added or subtracted to our variable. So I find my variable, and then I don't want anything over there with it, right? I just want in the end to have x all by itself and then all my numbers on the other side. So to undo this minus 3, I can add 3. Whatever I do to one side, though, I have to remember to do the same thing to both sides. Now, this is 0 plus 3 minus 3. And this is, the signs are different, so minus. 5 minus 3 is 2. Keep the sign in front of the big one. And over here we have x plus 0, which is just x. And it's fine to leave it that way, right? Your homework will probably turn it around and want you to put it in this way. But it doesn't matter if I say x is negative 2 or negative 2 is x. Really, both of those are acceptable. Okay, getting a little bit longer now, but still basically the same thing. I'm going to simplify each side of my equation before I start doing anything. Okay, so that's key. Notice before there was nothing on any of those equations I could do except move that one number away from my variable, and then I was done. Here there's a whole bunch of stuff going on. So I'm going to simplify both sides. So on this side, they're just two constants. I can add them together. And different signs means minus 2 is 0. Right? It doesn't matter if it's plus 0 or minus 0. Over here, these I can combine because they're like terms. The signs are different, means minus. 5b minus 4b is 1b. And then I have this constant term. So notice when we simplify our expressions on each side of the equal sign, then we wind up back with where we were. Oh, it's just one step. To get that b all by itself, let's add 6 to both sides because that makes this 0. So then 0 plus 6 is 6, and b plus 0 is b. And once you get it solved with one letter on one side of the equal and the number on the other, you've solved it. b is 6. Okay, this is just talking about the multiplication and division properties of equality, but we really already, I just threw that in when we were talking about the adding and subtracting. I could also multiply by both sides or divide as long as you do the same thing to both sides of the equation. Just remember, you cannot divide by 0. You cannot divide by 0. Okay? All right, so it's telling us to use the division property of equality. So when I look at my expression, I see that, oh, fine, just like before, we're going to find our variable, and any numbers on that side, I want on the other side. And since this time, though, that variable is being multiplied instead of added or subtracted, how do you undo multiplication? Is divide. Whatever I do to one side, I do the same thing to the other side. Now, that means over here I have 4 divided by 4. Anything that's the same in numerator and denominator can cancel out, right? And that just leaves 1s. And then on the other side, 24 divided by 4 leaves 6. Once you get one variable equals a number, you've solved it. Now, I want to caution us again. Use our notation correctly. Use our notation correctly. When you are dividing, put your division sign there. I see a lot of times students doing this. That's not correct, right? This means if I just look like this is an adding problem. This would be 4s plus 4, which I can't combine, and this would be 28, right? Likewise, I see other students who, even if you're adding, they always put the bar there, always, no matter if they're adding or dividing. Use the appropriate notation so that, for several reasons, so that when someone else is looking for your work, they can follow and understand what you've done. And so when you look back at your own work and trying to find a mistake, right, or check yourself, then you can also understand what you've done. So be careful with notation. Now this time, I have a number being multiplied, so I could divide by a half. I could do that. It's the same thing. 1/2 divided by a half, as long as you divide the same thing, you have the same value in the numerator as you do the denominator, it's going to divide and be a 1. So you could do that, but then over here I have 5 divided by a half. That's not too bad. Remember our complex fractions, we can't leave that. That's just 5 divided by a half, which is copy dot flip, right, 2 over 1. Okay, so I could do that, but this was a pretty simple fraction and a one-step thing. Something that might be better is think about, hey, if I have a fraction here, if I multiply by 2, right, I don't know why I put that on that side. If I multiply by 2, right, when you're multiplying fractions, anything that's the same in numerator and denominator can cancel. So over here, that cancels out, and I just have 1 over 1, or 1. And over there, 5 times 2. So this is actually going to be handy for us. Eventually, we're going to say my first step in solving any equation, from now through however far you guys go, calculus 1, 2, 3, whatever, you have an equation. First step, get rid of the fractions. So let's remember that. Now, I can't do it with an expression. But from now on, when I see a fraction, after we go, oh my word, a fraction, right? That's probably what we do when we see a fraction in our problem. But then we're going to say, hey, wait, is there an equal sign? Because if there's an equal sign, I can get rid of that fraction and I'll be like, yes. If there's no equal sign, I can just continue to go, oh my word, as I struggle to get common denominators and things, right? Okay. All right. So, same thing here. I need all of my variables on the same side, and they're already over there, but they're not simplified. I need to combine them so that I just have one variable. So signs are different. It means minus. 7 minus 4 is 3. Wise. Keep the sign in front of the biggest one. Okay, and now notice it looks just like those last two. Oh, I've got a number being multiplied by my variable, so to undo that, I'm simply going to divide by that number. Because negative 3 divided by negative 3 is positive 1, so 1 times y is y. Negative 12 divided by negative 3 is positive 4. Okay. This one, there's nothing to do but divide by negative 6, right? You find your variable. As long as both sides are simplified, you just undo whatever's being done to your variable. Since it's being multiplied by negative 6, if I divide by negative 6, I'll do the same thing to both sides. That means 42 divided by negative 6 is negative 7. And over here, negative 6 divided by negative 6 is 1. And 1 times w is w. Okay, so now I've got some simplifying to do first. Over here, all these are like terms. Notice what would make my math easier to do over here. I don't have to. I could go straight across, but if I use my commutative property, then 3 plus 7 is 10. I didn't have to think about my rules. Oh, and 10 minus 10 is 0. Or I could have said signs are different, so minus. 10 minus 3 is 7. Keep the sign in front of the bigger one, so negative 7 plus 7. Signs are different, so minus. 7 minus 7 is 0. Easier to think about our commutative property, though. Okay. Now, on the other side, I have terms that I can combine. So 1h plus 7h, that's 8 h's. I'm not done until I have just one h, though, so since there's a number being multiplied by the h, to undo it, divide. Do the same thing to both sides. 0 divided by anything, remember, as long as the 0's in the numerator, is 0. And 8 divided by 8 is 1, so 1h. You might think about this if you have trouble remembering that 0 rule, which one is which. Okay, think about if you have a number over 0, No, right? You can't do it. If the zero's on top over a number, it's like right on, okay, that's okay, right on. But if it says, if there's a number over zero, it's like no, no number over zero, no. Okay, just like we didn't care what 8 H's were or 6 Y's, I also don't care what -1 X is. I need one positive X, not a negative X. So remember, that means this coefficient that's being multiplied by that X is -1. So just divide both sides by -1. Because a negative divided by negative is a positive, and I'd have 1x equals 5 divided by -1, -5. Okay, now this is the list. You might want to write this down somewhere, go in and print this slide, whatever. But here's the steps that we're going to use now for simplifying or solving an equation. First of all, we're going to get rid of fractions. And we do that by multiplying with the least common denominator, but not inside parentheses. Don't forget that part. Okay, hopefully we'll see one in a minute and we'll look at why. Then we get rid of parentheses. Then simplify each side. Do any math you can do on each side of the equation. Move all the variables to the same side of the equal sign. Undo anything being added or subtracted to the variable. And then undo anything being multiplied to the variable. We've already practiced most of these steps. Let's just put them together now. And every time I solve a linear equation, which is all we're going to have for a while. Okay, when I solve a linear equation, I just follow these steps every time. All right, so let's go through the steps. First step, get rid of any fractions. This one doesn't have any. Get rid of parentheses. This one doesn't have any. Okay, simplify each side. Well, there's nothing to simplify on either side. I don't have any like terms that I can combine. Put all your variables on the same side. This one already has all the variables on the same side. So once you're in that position, undo anything being added or subtracted first. Remember our order of operations? Is please excuse my dear Aunt Sally. That's the order that we have to do our operations in. To undo then, which I'm trying to undo everything that's been done to that M to leave just a plain M, I need to undo stuff in the opposite order that it's done. I have to undo adding and subtracting before multiplying and dividing. Think about this, when you're getting dressed, you put your shirt on, you put your sweater on, you put your coat on. To get undressed, it's got to be coat first, then sweater, then shirt. So undo adding and subtracting first. So since there's a +1, I'm going to subtract 1. Do the same thing from both sides. That makes that a 0. So I just have 5m equals 16 minus 1. Now last step is always going to be undo anything being multiplied to your variable. So since there's a 5 multiplied times the m, I'm going to say divide both sides by 5, because 5 divided by 5 is 1 m, 15 divided by 5 is 3. Okay, I have an equation. Don't forget, now make sure you have an equation, because if you have an expression, that's a different thing. And pretty soon they're going to be mixed together. Okay, and so my first step really is, oh, is it an equation? Okay, if I have an equation, get rid of fractions, not any. Get rid of parentheses, not any. Simplify each side, don't have any like terms. Put all your variables on the same side, and we've already seen it really doesn't matter which side you move them to, but later when we have inequalities, it does. So I'm just going to get us used to, until we're really good at this, always moving my variables to the left-hand side. Okay? Okay. So that means I don't want any variables on this side. I want to reserve that for numbers only. So if I subtract 5x from 5x, there's a 0 there now. 2x minus 5x is negative 3x minus 2 equals 0 minus 11. Okay, once you get all your variables on the same side, undo anything being added or subtracted. Since I have a minus 2, I need to do a plus 2. Okay, that makes this 0. So negative 3x plus 0. And negative 11 plus 2 is negative 9. Now undo whatever's being multiplied to the variable. So I'm going to divide by negative 3. So x equals positive 3. Okay, same steps. Get rid of fractions. There is a fraction, but there's an equal sign. So yay, I can get rid of it. All we do to get rid of fractions is multiply by the least common denominator across every term. Every term. There's only one denominator, so that is my least common denominator. Now remember, this is a term. This 3/4 and this x, that's one term, right? I only multiply by things that are separated by plus and minus signs. Now 12 times 4 is 48, and over here the 4 and the 4 can cancel and just leave negative 3 times x. Oh, now that's a much nicer equation to solve. Okay, there's only one step to do. I could go through that same process, parentheses, not any. My variables are already on one side. Undo anything added or subtracted, there's not. So last step is always undo whatever's being multiplied to your variable. So in this case, that's a negative 3. 48 divided by negative 3 is negative 16. And negative 3 divided by negative 3 is 1. So 1 times x. Okay, I have an equation, so get rid of fractions. There's not any. Get rid of parentheses. Have some parentheses this time. I can't get rid of them by actually doing what's inside the parentheses, so I use my distributive property to get rid of them. 3 times y and 3 times negative 2. Now, there's no more simplifying I can do. All my y's are already on the same side, so undo whatever's being added or subtracted to the y. So negative 6 plus 6 is 0, and over here 3y plus 0 is 3y. Undo whatever's being multiplied to the y. Okay, 0 divided by anything, 0 on a number, that's on, right on. So my answer is 0 equals 1y. There's no fractions, so get rid of parentheses first. So everything else stays the same. We have 8 plus 5 times m plus 5 times 2 is 10 equals 6 plus 2m. After you get rid of parentheses, see if there's any more simplifying you can do on each side. And I notice that I have 2 constants on this side, so I can combine those. 18 plus 5m equals 6 plus 2m. Those are not alike. I can't combine those. Okay, when there's no more simplifying on each side to do, move all your variables to, and I'm going to say the left, or technically just the same side, whichever side you want. But to help us later, we'll always say the left. That means I want to get rid of however many's over here. So take away 2m. Take away 2m from both sides. So then I would have 18 plus 3m equals 6. Undo whatever's being added or subtracted to your variable. So take away 18. so that now I have no numbers over here. 3m equals negative 12. Undo whatever's being multiplied to your variable. So m equals negative 4. Okay, fractions again. Okay, I have an equal sign, so I can get rid of those fractions. First step to get rid of your fractions by multiplying by the least common denominator, which between 5 and 3 is 15. Right? We know how to go over and find our common denominator, so I'm going to multiply everything by 15. Each term, right? So right here, 15 divided by 5 leaves a 3. And over here, 15 divided by 3 leaves a 5. So that means what's right here, there's not a denominator anymore, but there's a negative 2 times 3 times n. And over here, there's a negative 1 times 5. Now that's a much easier equation to solve than one with fractions. And this wouldn't be too bad with just fractions, but when we have the fractions spread out with plus and minuses, that's when we have a giant problem. So now we're back to it's a one-step problem. The last step is always undo whatever's being multiplied by that variable. So n equals 2 negatives, make a positive. Five, 6. Okay, first step is get rid of fractions by multiplying by the least common denominator. I only have one denominator, so that means 3. Multiply every term. Remember, terms are separated by plus and minus signs. So this time, I actually have 3 things to multiply by that 3. Now right here, a 3 in the numerator and a 3 in the denominator will divide out and just leave 1 times c, or c. 5 times 3 is 15, and 7 times 3 is 21. Okay, there's no parentheses, all my c's are already on the same side, no simplifying. So next step, undo anything being added or subtracted to your variable so that you get no numbers over there. C plus 0 is c, and 21 minus 15 is 6. Okay, first step, if it's an equation, I can get rid of that fraction. Least common denominator, the only denominator is a 3. So let's multiply every term by 3 again. Okay, now I have negative 3 times 3 is negative 9. But right here now, this 3 and this 3 can divide out, so all that's left is 2 times y. And then 7 times 3 is 21. Okay, so now there's no parentheses or no simplifying, so my y's are on the same side. So I'm going to undo whatever's being added or subtracted to my variable so that there's no number over here. So this is negative 30 equals 2y plus 0 is 2y. Undo whatever's being multiplied or divided. Whatever's being multiplied, sorry. If you get rid of fractions, it'll always be get rid of whatever's being multiplied. Negative 30 divided by 2 is negative 15. 2 divided by 2 is 1, so 1 times y is y. And once you get your variable on one side and a number on the other, so we have y equals a number, it's solved. Okay, let's see what we have here. The expression for notice it's an expression, not an equation. Oh, and this might look familiar. For finding a person's approximate systolic blood pressure is 100, plus their age over 2. We had this earlier where they just had an A. Suppose your friend's systolic blood pressure is 116, and suppose his has a normal blood pressure. Find his age. Remember before when we had this as an expression, it gave us the age and we could plug in. Okay, but this, with this is, so this is systolic blood pressure is this. So it's given us an expression. And it's telling us the systolic blood pressure is means equals 116. So it's giving us the equation in word form though, and I have to know to put that together as an equation. Okay, so if I'm now going to solve this equation to find his age, when I solve it for A is his age. First step, get rid of fractions. That means let's multiply everything by 2. Okay, that means we have 200 plus 2 divided by 2 is 1, so plus 1A equals 232. Undo whatever's being added or subtracted to the variable. So that 0 plus A is A. 232 minus 200 is 32. Your friend must be 32 years old. Okay, so that should do it for this section. Let me know if you need anything. See you next time.